All right, so we're now going to get into multiplying and dividing numbers that are written in scientific notation. I'm going to briefly and quickly go through rewriting these numbers into scientific notation. I'm not really going to explain it much because it is something that you would have learned before. But if you don't remember how to convert these numbers into scientific notation and want more of a thorough explanation, there'll be another video on Edpuzzle that you can watch, but it's not mandatory if you already know how to do it. Just remember, when we are doing scientific notation, we're converting both of these numbers into where we have one digit in front of the decimal that needs to be between 1 and 9. And then if there's any other numbers that are non-zeros, we follow them after the decimal place. And then we are going to be multiplying it by 10. And that 10 will be raised to a positive number or a negative number. So it could be 10 to the fifth power or 10 to the negative fifth power, because that's telling us how we're moving our decimal, or ultimately if we're dividing or multiplying by that 10 raised to a power. All right, so we're just going to go ahead and convert these into our scientific notation. So I know that this is going to have to be written as 2.53 because I need the number in front of the decimal can just be a one digit between 1 and 9. So I'm rewriting it so it's 2.53, and then it's going to be times 10. So here we're finding our decimal place, and we're counting 1, 2, 3, 4, 5, 6. So it's going to be times 10 to the sixth power. This should hopefully make sense now that we are learning these negative and positive exponents as well, that if 10 is being raised to the sixth power, that's actually meaning 1 million. So if I'm multiplying 2 by 1 million, my number is going to be getting larger. And since I shrunk my number to begin with, to get back to the original number, I do need to multiply it by a bigger number. So hopefully this makes sense as to why that's a positive power. When we go to do our next one, this I see 3 and 2, so it's going to be 3.2. But now since my number is a decimal and I'm making it larger, I'm counting to the right, 1, 2, 3, 4 decimal places. This is actually going to be times 10 to the negative 4. And we can think about this as well. We just learned that a negative exponent means that it's going to our denominator. So this is essentially saying 3.2 divided by, we're flipping that 10 to the negative fourth power to the denominator. So it's going to be divided by 10,000. So this is just something that should maybe make a little bit more sense as to what this number is actually representing now that you can understand we're dividing by this. So it is telling us that it's going to be a smaller number. And that's why we're multiplying by negative, because here 3.2 is bigger than the 0.00032. So in order to get to a real number, we need to make sure we're dividing, making it smaller. All right, so that's just real quick of going through. When we're moving our decimal place to the right, we are subtracting our power. When we're moving our decimal place to the left, we are adding our power. That's essentially what you just need to be able to remember, because when we get into this next part of our operations, we just need to be able to manipulate our decimal value here and there. All right. For this part, you will be able to use a calculator to multiply the numbers out front, but you're not going to be able to plug this into your calculator because it's going to end up giving you a large number anyway. And I will want to see the steps just like in the last one. So even if you can plug it into a calculator and gives you your answer as a final answer, if you don't show me the step in between where if you needed to rewrite your value, like your number, you won't get full credit for it. And you'll know what I mean in just a moment when we go through a problem. All right, so now we're multiplying two scientific notations together. So when we do this, we can rearrange this a little bit and say, okay, well, just like we can multiply our coefficients, we can kind of treat these as if they're coefficients, even though they're not. But we can think about them in that sense, and we can then rearrange and say, okay, I'm going to multiply 5.6 times 2, and then I'm going to multiply the 10 to the fourth power times 10 to the 11th power. And now we can go ahead and multiply. Since these are like bases, we know that we add our exponents when we're multiplying. So 10 to the fourth times 10 to the 11th is equal to 10 to the fourth plus 11, or 10 to the 15th power. So I know that this now is going to be times 10 to the 15th power. And then we will multiply 5.6 times 2. And this, I mean, you can use a calculator for this part if you need to, but 5.6 times 2 is going to give me 12 carried to 1. 5 times 2 is 10, plus 1 is 11. It moved one decimal place, so we move one decimal place, and this now becomes 11.2 times 10 to the 15th power. This is a step that you have to show me. If you use a calculator, I'm okay with it, but you need to show me this step here, because if you just type into a calculator and it gives you your final answer, I need to make sure that you can do this and not just being able to type it in. So here we're getting this 11.2 times 10 to the 15th power. This is not in scientific notation, though. All right, this is not in scientific notation. written as 11. So we need to rewrite this. So that means that this decimal place needs to move one more spot to make it 1.12 times 10. And now we're saying, okay, is this going to be 14 or is this going to be 16, our power of 10? And since this number got smaller, and in order to go back to the original number, it needs to get larger, that means that we're adding to this. Or remember, as we move to the left, we add. As we move to the right, we subtract. You can just remember that as well, so that this actually becomes times 10 to the 16th power. All right, so when we're multiplying, and as you're going to see, dividing, scientific notation, we just multiply or divide the numbers that we have, like the 5.6 and 2, and then we use our exponent laws to either add or subtract those powers for that scientific notation. All right, so there's just maybe one or two more questions we'll go through, and that'll be it for this. All right, so for this one, we have 4.4 times 10 to the 5th power divided by 2 times 10 to the negative 6. Personally, I like to just write these as a fraction, simply because it just allows me to see my rules a little. Whoops, that's times 10 to the negative 6. My rules is a little bit clearer. So when I do this, I'm going to first focus on my numbers out front of the scientific notation, and then I'm going to solve my scientific notation numbers. So first I'll do 4.4 divided by 2, and that is going to give me 2.2. So by doing this right away, I'm like, oh, okay, this is great. I don't have to worry about manipulating this number, this digit. It's already kind of starting to be written in scientific notation for me. Now the difference is, before, when it's variables, we would always say, where do we have more at? We are going to just use our rule and always do our numerator minus our denominator. All right, because in scientific notation, we don't write 1 over something. It's just times 10. And if that power is a negative or ends as a negative, we don't need to rewrite it as positive, because that's just telling us it's going to be a decimal. So in scientific notation, we don't have to worry about where it's going or changing that power to a positive. That power can remain negative, and that's perfectly fine, because it's telling us which way we're going, and it's already telling us if it's in the numerator or denominator. So we always will do our top minus our bottom. We don't think about what we did before. This one does work out that we do have more in our numerator, but we always will just do the 10 to the 5th divided by 10 to the negative 6. So we're always going numerator minus the denominator. So in this case, we know our rule is we subtract. So 5 minus negative 6, well, that actually turns to plus. So that then becomes times 10 to the 11th power. All right, so when we're dividing, same thing as before. We treat the numbers that we have out front of that times 10 to the power, and we do the multiplication division with them, and then we just use our rules that we learned with our exponents to simplify this a little bit more. All right, so that's this question. Let's go ahead and do definitely one more with division, maybe another one with multiplication. All right, so for this problem, we have 2.5 times 10 to the 6th power divided by 5 times 10 to the 10th. So here I'm going to rewrite these on a fraction, just so this way maybe it makes you a little bit easier to remember your rules as far as dividing with like bases. I'm going to first focus on my numbers out front, so 2.5 divided by 5, and then I'll focus on my times 10 to the power. So 2.5 divided by 5, you can use a calculator for this. I'm perfectly fine with that, but we'll have 0. So now we're moving to this 0.5 part, so I need to put my decimal, and 5 goes into 25 5 times, with a remainder of 0. So I know that this is going to give me 0.5. Now our rule is we are going to be times, we always do with scientific notation, numerator minus denominator. We don't worry about where there's more at. And then we're going to just go ahead and use our rule where we're subtracting. So 6 minus 10 is going to give me 10 to the negative 4th power. So this is times 10 to the negative 4th. All right, so now this is not in scientific notation, so I do need to rewrite this. So I'm moving it one decimal spot to the right to change that into a whole number. I don't need to write times 0 if I want to, but we will. For now, it's 5.0 times 10. When I move to the right, I need to subtract, because this number, we're making it bigger, so we need to actually think about it as a smaller number in our real life. So then we will do negative 4 minus 1, which is then going to give me times 10 to the negative 5th power. All right, and that's it for this video. And if you guys need any help with the scientific notation of going back and forth, just make sure you're watching the other video that's out there.